Hey guys, I wanted to show you guys our application that we've done for our cloud computing final project. The name of our application is Libra. It is a microservice, well, it's a cryptography system that has a microservice architecture, which we've built in Spring and deployed using Amazon Web Services. So anyway, what I want to do, I want to start here in the source code. And you can see here that we have our, this is one individual microservice. This is actually our gateway. And we have various controllers here. We have message controller, plaintext controller, cipher controller. We also have some tests, which I'll talk about in a second. But before we actually get into what the application is and what it does, I want to spend a little time going into detail about how it's deployed. So we're using a continuous integration pipeline, and to demonstrate that, what I'll do is make a small change to the README here. So I'm just changing this little emoji, and I'm going to push this up to our repository. You can see down here that I'm on my own branch called Libra Gateway, and I'm going to commit and push this. So this is going to get pushed on my branch. And as soon as that's done, what I will then do, I'll go over here. This is where our repo is hosted on GitHub. And I'm going to go to my branch and open up a pull request. So here I'm just updating the README. We're going to create a pull request. And then I'm going to merge this pull request like that. Confirm merge. And as soon as my branch has been merged into master, because master is the tracked branch in my code pipeline, you can see here, this is now the Amazon console, that the first part of my build pipeline has been initiated, which is gathering the source through Amazon code commit. So it's the first Amazon service we used to make this project possible. And right after we collect the source, the second part of the build pipeline is to actually resolve the dependencies. Here we're using Maven as our dependency resolver, and then execute or run the tests. And so the way the build pipeline works, now that it has the code, it wants to create an artifact. Spring starts as a jar, so we need to actually build that jar. And to do that, we need to combine our code with all of the dependencies that are specified in our POM file. And furthermore, we can customize how the build pipeline works by specifying something called a buildspec.yaml file that's provided to us in the Amazon documentation. Here is our POM XML. This is just standard Maven. We list out our dependencies, and that's what we use to actually build the individual microservice. And lastly, we have something called a Docker file. And so what this file does, the Docker file and the build spec file are both in the root folder of our repository. This specifies how we want our application to start once it is deployed to a container, or rather, once our artifact has been baked into a container image. So you can see this Docker file is very, very simple. We're using OpenJDK 8 Alpine. We're creating a volume called temp. And then we're adding this jar, which is called Libra snapshot, as app.jar. So we're just renaming it to something a little easier. We are exposing port 8080. So we're exposing a port within the container 8080. That's what this application is configured to run on. And then because ultimately when we deploy it, we'll be using an Nginx gateway to proxy requests. We'll proxy port 80, which is the standard HTTP port, into port 8080, which is what's being exposed by this container. And then all we do is we basically start the jar. So as soon as this container starts, we already have a artifact, which is the result of our build, baked into the image, and then all we do is we simply start that. And because Spring works the way it does, it's just going to start our whole server, and that's basically how it works. It's pretty straightforward. So now you can see here, going back, the build is done, and we've also been able to successfully deploy it. So the first service we used is code commit. The second service we used is code build in order to create an artifact. And the third service we used is Amazon Elastic Beanstalk, which is what we're actually going to use to host our application. So if I open it up, you can see here that I actually have 4 different microservices. But for demonstration purposes, we only care about this gateway service, which is what we're going to be using to actually interact with our app. So here, this is the environment, it's healthy, and here we're given a URL, which is how we can actually access it. So going to this URL, I can actually load my Swagger, and now here I have all of my APIs, which are brokered through my my Libra gateway. So this is what we're going to do here. Now that we actually have this app deployed, we're going to do something called hill climbing. Hill climbing is a cryptographic algorithm that is used to try and break homophonic substitution ciphers without a key. So homophonic substitution cipher is special. It basically means that they're very hard to crack with dictionary attacks and chosen plain text attacks and stuff like that. So what we're going to do, we're actually going to break this homophonic substitution cipher without a key, which is kind of interesting. And I'm going to use the first microservice to actually generate a message. So this is a plain text message randomly generated from a dictionary of length 500. You can see it's just a bunch of random words that are pulled out of a dictionary to make a message. And the first thing I have to do once I have the message is actually go and encrypt that. And so I'm going to paste this message here, and now we're using our second microservice. You can see that I'm given a ciphertext, and I'm also given something called a digraph. And a digraph is a model. It measures how often letters occurred next to each other in the original message. So we don't have a key, but we're given this model, which helps us, kind of gives us some hints as to what the original plaintext might be, despite the fact that obviously we don't have the original plaintext and we don't have a key which we can use to decrypt the ciphertext. So I'm going to copy this response here, which again is our ciphertext in our model, and we're going to use our third microservice, which is a decryption service. Now, hill climbing does not work all the time. It's a heuristic strategy. So we may not get something that is exactly what we expect, but frequently we're able to get things that are very, very close, if not perfect. So we're going to try it out and give it just a minute here while it does some computations. So what it's actually doing in this phase, it chooses a random key that it tries to guess, and then it tries to decrypt the ciphertext with the random key, and it gets something called a putative plaintext, which is a plaintext that is not correct. But it will calculate, it will take that putative plaintext, which is just basically random junk, and compute the digraph of that. And we'll then compare the digraph of that putative plaintext to the actual plaintext digraph. Then what it's actually doing now is it's swapping things inside the key. Okay, so we get something that's not quite perfect, right? But I do want to try it one more time. So we get something that is how should I say? We start swapping keys until we get something that is very close. So I want to try a second message here. Offend, prefer, rural, preach. We'll copy this here. Same process. So here we'll delete this. And now we'll get the new ciphertext and the new digraph. Oh, sorry. Hold on. I wish there was an easier way to copy this, but it is what it is. Sorry, guys. To do build a UI, that would be pretty nice. Okay. So now we have our ciphertext and our digraph again. Okay, so we do want to have at least one example where this actually gives us something that makes sense. And it's usually a lot more accurate than this, but that's okay. So same process here. Awesome. Okay, so that's great. We actually get the original plaintext back, and that's without any keys, or it's just using the hill climbing algorithm to compare models. It's almost like kind of a little bit like a machine learning style thing. But anyway, that's what we wanted to show. Thank you for taking a look at our demo. We really appreciate it. Enjoy the summer.